Welcome to our session on how to name and identify alcohols, aldehydes, and ketones. Now, alcohols are the homologous series of organic compounds which contain one or more OH functional group. Now, what's important to note here with the OH functional group is that it is not a hydroxyl. It's not a hydroxide, I apologize, but it is known as a hydroxyl. The R in our structural formula is any length of carbon atom, so the OH has to be attached to a carbon. The general formula is CnH2n plus 1 OH. This is only valid if there is a single OH attached to the carbon chain. However, there can be more than one. Here, what we have is an example of a few to start off with. The first one is ethanol. Eth because we have two carbons in the longest chain, and OH because we have an OH attached to it. Propanol because we have three in the longest chain. However, it is propan 1-ol because the OH is attached to the first carbon. The next one is propan 2-ol because even though we have three carbons in the longest chain, the OH is on the second carbon. And of course, we know that if the OH changes position, then it is a different carbon altogether. Alright, it's a different compound and it has different properties. The next one is butan 2-ol, the but because there are four carbons in the longest chain, and the 2 because the OH sits on the second carbon. When we name alcohols, it's important to identify the longest carbon chain, just like with any other. Though, the carbon chain must have the OH attached to one of the carbons. When we write the name, you write it like an alkane, but instead of an E, we have an OL. Please make sure that your O looks like an O and not an A. Indicate the position of the hydroxyl group by assigning the lowest possible number, just like we have done in other examples. If there are two hydroxyls, like in the example shown, then just as with if there's two double bonds or two triple bonds, we call it a di. So di means two. This is a diol because there are two OHs. We need to number both of them, and they're on 1 and 2, and it's eth because there are two carbons in the longest chain. We can classify alcohols as primary, secondary, or tertiary. Now, primary alcohols are easy to spot because the OH is on a terminal carbon. In other words, it's at the end of a chain, and this would then make it 1-ol. So if you look at this one, this is ethanol. We're not worrying about numbering it because it can only be on number 1, propan 1-ol, and here we have propan 1-ol, 2-methyl propan 1-ol. The OH must be on number 1. That's the important thing. Good way to see if you have a primary alcohol is if you have a 1 in the name. Okay, so you've numbered it on number 1. It's just one of those things. For a secondary alcohol, we now have the OH attached to a carbon that has two other carbons attached to it. So if we look at propan 2-ol, okay, the carbon over there is where the OH is. There are two other carbons attached to it. That makes it a secondary alcohol. If we look at the next one with butan 2-ol as well, two carbons on either side of the carbon with the OH. Same with pentan 3-ol, two carbons on either side of the carbon with the OH on it. That gets us to our third one, which is tertiary alcohols. Tertiary alcohols are alcohols where the OH is attached to a carbon which has three other carbons attached to it. This means that the carbon that the OH is attached to must have a methyl, ethyl, etc. branch attached. So if we look at these ones, my carbon with the OH is there, and here are the three carbons that are attached to it. So it's 2-methyl propan 2-ol. So please understand that this won't be a simple name. There will be branches attached. Here we have three carbons attached to the little carbon with the OH attached to it. Okay, so let's look at some examples. It says name the following alcohols, also state whether they are primary, secondary, or tertiary alcohols. So when we look at these, oops, sorry about that. What we need to look at is we are going to look at how we name them, okay? And remember, when we name these, it's important. So, when we name these, remember, it is important to always number correctly and to make sure we know where each of the things are. And with the OHs, you generally aren't going to have to put a number in them unless it's a really small one, like an ethanol. Okay, so the first thing we do, like we've done with everything else we've done up till now, is we need to identify the longest chain. So we look at this one, and it's 1, 2, 3, 4. So that makes it a butane, okay, because it's 4. We have an OH, so we know that it's going to be OL. And we have a methyl group, so I know it's going to be methyl something, methyl butane something ol. So now we're going to look at the numbering. In terms of the hierarchy of our numbering, the OH is more important. So if we go from left to right, always try to start from left to right. 1, 2, 3, and 4. So that puts the O on 2 and the methyl group on 3, and that's great. Part of the question that we're looking at also asked you to identify if this was a primary, secondary, or tertiary alcohol. My alcohol group carbon has 2 friends, 2 carbons on either side of it. That makes it a secondary alcohol. Okay, let's move on to the next one. Now we look at the next one, and once again, we start in the same place we start with all of them. We start with finding the longest chain. 1, 2, 3, 4. So because I know it's 4, that means it's going to be butane. So just like we had before, and we have an OH, and we still have a methyl group. So I know it's going to be methyl, butane, something. Oh, and I need to know where the methyl is. All right. So looking at this, if we number from left to right, what will happen is we'll end up 1, 2, 3, and 4. So the OH ends up on 4 and the methyl's on 2. Not too happy with those numbers. Let's go the other way around. So let's do 1, 2, 3, and 4. That means that now my alcohol can sit on number 1 and my methyl can sit on number 3. Much better way to do the numbering because we have the smallest group. Now we look at the carbon that the OH is attached to, and that carbon only has 1 friend, so that makes this a primary alcohol. Our next one, here we go. Once again, we look for the longest chain. 1, 2, 3, 4, 5. Great. 5 in the longest chain, that means we know that we're going to have pentane. Okay. We need to know where the OH is. And of course over here we have the methyl group. Alright, now the thing here is that my alcohol and my methyl group need to sit on the same carbon. Otherwise this carbon won't have 3 friends, won't have 3 other carbons next to it. So it's 1, 2, it's on the 3rd carbon. So there we go. And this will be a tertiary alcohol. Alright, so at this point in time, in your textbooks, grade 12s, you can go to activity 2 on page 95 and look and try and complete questions 1.1 to 1.3 and question 3.1. You might want to pause the video here while you do that, or of course you can just carry on and look at aldehydes now. Moving on to aldehydes. Aldehydes are actually really nice. If you can identify the functional group easily, they become one of the easiest ones to name because an aldehyde has a double bond to the oxygen only on the last carbon. It's known as a carbonyl group, okay, that double bond oxygen, but it's got to be at the end. It's got to be terminal, which means it actually has to sit on number 1. It has to be our first carbon when we look at it. So if there's anything else attached to an aldehyde, like a methyl group, we know where to start numbering. All right, so we identify the longest chain. We identify the longest chain, which is what I said, and we write the name as if there was an alkene, except we place the E with an AL. And this is where your handwriting is so important, because if it looks like an OL, you're going to get it wrong. Once again, longest chain, 1, 2, 3, 4. That makes this bute. And this would be butan L because it's got an AL. Next one, 1, 2, 3, 4, 5, 6. That makes it hexane L. Very simple. Moving on to ketones. Now the difference, remember, between an aldehyde and a ketone, which can be functional isomers of each other, is that a ketone has a double bond to an oxygen somewhere in the middle of the chain. Cannot be on number 1. So, remember, the thing here when we look at our general formula is that the R and the R dash are any length of carbon chains on either side, but they must be carbons. Okay? Has to have the carbonyl group somewhere in the middle. Here, when we write the name, we replace the E with an O, with one, O-N-E, okay? But we must now indicate the position of the carbonyl group because it's important. It is obviously more important than any of the other functional groups we've done so far. So if we look at these two, yes, the name's already there, but let's see how we got it. Longest chain, 1, 2, 3, 4, 5, which is where the pentan comes from. When we look at numbering, 1, 2. I've gone from the left so that the O sits on the second one. If we go from the right, 1, 2, 3, 4, it sits on number 4. That is too big. When we look at heptanones, the other one here that we've got, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Apparently I can't count. Here's my hept, so it's heptane. 3 own because we're numbering from the left. Okay? Right. Please now do activity 3 on page 97 of your textbooks, questions 1 and 3.